Today, we're diving into some incredible new research that reads almost like a detective story. We're going to be hunting for the absolute earliest, tiniest clues of Alzheimer's disease. Clues that might show up years, even decades before someone's memory starts to fade.
I mean, this is the ultimate question, right? What if we could see the storm clouds gathering long before the rain ever starts to fall? Well, a recent study took on that exact challenge, and how they did it is just fascinating. So let's get into it.
You know, this whole investigation starts with people who just have a feeling that something with their memory just isn't quite right. They go to the doctor, they take all the tests, and everything comes back normal, but they still feel that something has changed. This is what scientists call subjective cognitive decline, and it's the perfect place to start looking for the very, very first signs of trouble.
So, if you're a scientist, how do you even begin to look for something that's practically invisible? Well, you're going to need some seriously high-tech tools. Let's take a look at what these researchers were hunting for inside the brain. Okay, so the number one suspect in the Alzheimer's story is this sticky little protein called amyloid beta. When too much of it builds up, it starts forming these things called plaques in the brain. And here's the kicker. This can start happening decades before anyone notices a memory problem. So the goal is to catch this buildup as early as humanly possible. To actually measure this amyloid, scientists use PET scans and this really clever standardized scale called the Centiloid scale. The analogy on the slide is perfect. Just think of it like a risk thermometer for the brain. A low number means you're in the clear, very little amyloid. A high number, well, that means there's a lot. All right, so with their tools ready, the researchers gathered 197 volunteers, all of whom were experiencing that subjective cognitive decline. And the very first thing they did was measure everyone's amyloid levels right at the start of the study. Okay, now this chart might look a little complicated, but it's basically just a sorting machine. The researchers took every single participant, and based on that initial brain scan, they put them into one of three buckets. You had the amyloid negative group with really low levels, the amyloid positive group with a pretty significant buildup, and then this crucial middle group they called the gray zone. And get this. At the very beginning, a massive 86% of people were in that so-called safe amyloid negative group. Just a tiny fraction were in that gray zone or were already positive. This is so important because it really sets the stage for what they discovered later on. Now, the researchers didn't just take one picture and call it a day. Oh no, they followed these people for 5 full years, tracking both their amyloid levels and their cognitive health. So what happened over time? Let's see what they found. Wow. The results were incredibly clear. As this chart shows, the folks who started out in that gray zone or the amyloid positive groups, they had around a 60% chance of progressing to what's called mild cognitive impairment. Now compare that to just 18% for the group that started out negative. The connection is just undeniable. More amyloid at the start meant a much, much higher risk down the road. This chart here is called a hazard plot, and it shows us exactly what factors cranked up the risk the most. It's actually super simple to read. Any factor whose little black square is to the right of that dotted line is a significant risk. You can see being in the gray zone, being older, and having less education all nudge that risk higher. But look at the one on top. Having high amyloid at the start was by far the biggest risk factor. I absolutely love this visualization. They call it a spaghetti plot. Each one of those lines is a single person's amyloid journey over those 5 years. You see all those stable gray lines bumping along the bottom? Their levels barely changed. But those colored lines, the ones shooting upwards, that's a totally different story. Those are the people whose amyloid levels were actively climbing, and some of them were climbing really, really fast. So here's the million-dollar question. Who was accumulating this stuff the fastest? Well, this plot gives us the answer plain and simple. See those green dots way up at the top? That's the gray zone group. They were in the fast lane, accumulating amyloid even faster than the group that started out as positive. This tells us the gray zone isn't some quiet waiting room, it's a period of rapid, critical change. But you know what? The most incredible discovery didn't come from looking at the high-risk groups. It came from looking at the group that everyone thought was the safest. This is where their real detective work paid off big time. Remember that huge group of amyloid-negative people from the start, the 86%? Well, it turns out that even within that lowest risk group, nearly 1 in 5 of them, 19%, were silently starting to accumulate amyloid over the 5 years. They were supposed to be the healthy control group, but something was clearly happening under the surface. And here it is. This is the smoking gun.
The researchers went back and compared the day one brain scans of the people in that safe group, and they found this: a tiny, subtle hotspot of slightly higher amyloid in a part of the brain called the precuneus. This little signal, highlighted right here in red, it was there from the very beginning, but only in the people who would later go on to accumulate more amyloid. It was the earliest detectable clue they could find, an echo of the future. So we have this tiny, tiny signal that can predict future change. What does that actually mean for the fight against Alzheimer's? This is the really important part, so let's break down the impact. Okay, here's the bottom line. First, this proves that we can potentially spot risk at the very, very earliest stage, even before it crosses any official threshold. Second, it confirms that gray zone is a critical window where we might be able to intervene. And maybe most importantly, this is a game changer for developing new drugs. We can now identify the absolute perfect candidates for clinical trials, people who just have this tiny signal. It lets us test treatments designed to stop the disease before it ever really gets started. And that's what leaves us with this incredibly powerful question. Think about it. We've just gone from a vague feeling someone has about their memory all the way to a specific, measurable signal in their brain that can predict the future. This research doesn't just give us clues anymore. It gives us a target. And with that target, it gives us a whole new sense of hope.